Hello guys, welcome back to another video. In this video we are asked to evaluate the following integral. An integral from 0 to pi over 3 ln of 1 plus square root of 3 tangent of x dx. Okay, this integral, first of all, this integral looks really weird, and I don't know like if you can solve it with partial integration or something, but I don't think so. So this one is tricky, and so let me show you here how can you actually evaluate it. Okay, so we have from 0 to pi over 3, and you're asking yourself like, what can I do with this? So let's just introduce a substitution. Pi over 3 minus x equals to t. And now you're wondering why that? I mean, like pi over 3 minus x, where x is pi over 3, this will give us 0, and this will give us pi over 3, and we will flip the boundaries. So maybe something will happen here. So let's see, maybe something will happen. Okay, of course, negative dx equals to dt. Okay, so we get pi over 3 here, right? And we get 0 here, as we said. Ln of 1 plus square root of 3 times what? We can solve this for x. So not for x. Okay, yeah, for x. We need it for x. Okay, we flip that on the right side. We get t on the left side. So x equals pi over 3 minus t tangent of pi over 3 minus t. Okay, let me get this out of the way. Okay, this looks better. Tangent, yeah, times negative dt. Okay, this is what we have. We will use the negative sign to flip up the boundaries, so we get the following: an integral from 0 to pi over 3 ln of 1 plus square root of 3 tangent of pi over 3 minus t. Is it enough? Like, this is for the tangent, yeah, and this is for the ln, okay, dt. So, and you're wondering what the fuck is that? What the fuck is this? Okay, I don't know. Let's evaluate it. Okay, where should I write that? Okay, maybe here, I don't know. Okay, maybe here, okay? So what's tangent? It's sine over cosine, right? For example, t, this is tangent t. So when we have pi over 3 minus t, it's the same like as putting here pi over 3 minus t. So pi over 3 minus t and cosine of pi over 3 minus t. Okay, this is what we have. Okay, now we need to know the formulas, but it goes, I think, like sine of pi over 3 cosine of t minus cosine of pi over 3 sine of t. I hope this is correct. Okay, over, we have like the same things, I think, like cosine of pi over 3 cosine of t plus sine, okay, sine of pi over 3 sine of t. Okay, when we evaluate this, this is square root of 3, this is the maximum. Okay, square root of 3 over 2. Okay, cosine of t plus, okay, this was cosine, not, okay, this was sine, okay, sorry, I watched this, okay. So from this we get this cosine of t, and it's the minus. It's the minus, not the plus. Okay, minus cosine of pi over 3, that's 1/2 sine of t. Okay, this two can be written a bit better. Okay, this looks better. Over, and now this is 1/2 cosine of t plus square root of 3/2 sine of t. And now you're like, what the fuck should we do now? Okay, so let's take let's factor some things. Let's factor cosine of t over 2 here. Up, what do we get? Square root of 3 minus, this is sine over cosine. I factored something that isn't there, so it should be like sine of t over cosine of t. That's tangent. That's tangent of t. And over, I will do the same on the bottom. Cosine of t over 2. This is s. Okay. Okay. What do we get here? We get, this is simply 1, I guess, plus this is sine t over cosine of t. So this is like tangent, but this is square root of 3 also here. So it's square root of 3 tangents of t. Okay, these things cancel out, and we are left out with this. Okay, square root of 3 minus tangent of t. Okay, tangent of t over 1 plus square root of 3 tangent of t. Okay, so let's replace this with that. Okay, here. Okay, an integral, we don't touch this. Okay, an integral from 0 to pi over 3 ln of 1 plus square root of 3 times square root of 3 minus tangent of t over 1 plus square root of 3, okay, tangent of t. Okay, this is what we get. And let's I won't write a lot of lines for this. Let's just do some algebra. So what do I mean by that? Okay, I didn't mean to do this, of course. Tangent of t. So what do I mean with that? Like 1 will be multiplied by this, and square root of 3 will multiply this. So let's just work it out. For example, here, like I don't want to use more lines for nothing. Okay, 1. Okay, this times this, it will be 1 times 1, that's 1, plus 1 times this is square root of 3 tangent of t. Okay, plus square root of 3 times this, so this is 3 minus square root of 3 tangent t. Okay, this is written bad. Okay, square root of 3 tangent t. Okay, so let's solve this out. This and this gets cancelled out. We are left out with 4 over this. So this okay, this should be like this. Okay, this equals to an integral from 0 to pi over 3 ln of 4 over 1 plus square root of 3 tangent of t. Tangent, oh my god, why can't I write tangent? I don't know. Like tangent of t. What? Okay, so this is what we have. So what can we do with this? Like, we can use the logarithm property and split up this like into two logarithms, right? Okay, this equals an integral from 0 to pi over 3 ln of 4 minus an integral from 0 to pi over 3, okay, dt, okay, dt, pi over 3 ln of 1 plus square root of 3 tangent t. Okay, this is what we have. Okay, you can see if we call this I, if we call this integral I, like this is also I. So our integral is equal to I. Okay, this is a constant. This is dt. Okay, this is badly written dt. Okay, this is dt ln 4. Ln 4, I mean, it's like 2 times ln 2. I mean, it's nothing special. Times pi over 3. It's just a constant. We are integrating a constant. So we get this from here. And this integral is same like this. Okay, so it's minus I. Okay, it's minus I. And now, how do we end this? Okay, we flip this to the other side, and we get 2I equals to 2 ln of 2 over 3. And now what happens? We flip this down, so we get I equals to ln of 2 over 6. This and this gets cancelled out, and we are left out with ln of 2 over 3. Okay, but where is pi? I mean, okay, it's missing. I was like, where is pi? I mean, we must have pi because of the integral. I mean, pi. Okay, so here it is. This problem was a bit harder, maybe, like which substitution should be used. But I think this integral is pretty cool, and the answer is also pretty cool. Like, we have division, ln 2, like an odd number, and pi. So this is pretty cool. Okay, that was it for this video. I hope you enjoyed this. Like, share, and subscribe if you want to see more of this. And see you in the next video. Bye, guys.